Hi, Dr. Schallenberger here for part 4 of this video series entitled Disease is Optional. You can opt out if you want to. Hopefully you want to. In this particular section, I'm going to talk about the absolutely critical importance of dietary fat and carbohydrates to mitochondrial function, and how we can determine using bioenergy testing technique what is the correct ratio of fat to carbohydrate for your particular mitochondria. So let's get on with it. This is what we're going to look at. How your mitochondria use fat and glucose to produce energy. For primary fat burners, there are people that are what I call primary fat burners. You'll learn about this in a sec. And primary carbohydrate burners. Which one are you? That's important for you to know. If you're a primary fat burner, you're going to have decreased mitochondrial function if you eat carbohydrates. Also, if you're a primary carbohydrate burner, you're going to have decreased mitochondrial function if you don't eat enough carbohydrates and eat too much fat. So which one are you? What is the optimal diet composition for your particular mitochondria? That's what we're going to talk about today, and that's pretty critical. So here's how your mitochondria use fat and glucose to produce energy. The oxygen goes into your cell, eventually finds its way in the mitochondria. And in your mitochondria, you basically have fats, got fatty acids, and you have glucose. Glucose is sugar. It's your basic sugar that the cells burn. It all comes from carbohydrate, not all of it technically, but from a dietary perspective, glucose comes from carbohydrate. So that's where you get it. But so when the oxygen goes into your mitochondria, it actually can either burn fat or it can burn glucose. But here's the issue. For genetic reasons, some people with their mitochondrial genetics are not suited to burning sugar or glucose. Other people, for their genetics, are not suited to burning fat. So which are you? We can determine that from bioenergy testing, and it's very cool how this can be done. Kind of works like this. When you're burning fat, when your oxygen is burning fat to produce energy, less CO2 is emitted. When your cells are burning glucose for energy, more CO2 is emitted. So if I look at the ratio between oxygen and carbon dioxide, while you're just sitting there in a chair, if that ratio of carbon dioxide to oxygen is higher, I know you're burning primarily sugar. If it's lower, I know you're primarily burning fat. And what's beautiful about this is that this is a linear equation, which means that as you go from one extreme to the other extreme, it's linear and predictable. So by looking at the ratio of CO2 to O2, I can tell you exactly, are you a primary fat burner, or are you a primary glucose burner, or are you something in between? Because you basically have two extremes, and then the rest of us kind of fall on a continuum between those two extremes. On the one extreme, you have people whose mitochondria just are so inefficient at burning glucose, in order for the mitochondria to work well, they have to burn fat. If for some reason they can't burn fat, they're in trouble because they don't burn glucose that well. On the other end of the other extreme would be somebody whose mitochondrial genetics do not burn fat very well, and they prefer to burn carbohydrates. If they don't get enough carbohydrate, they don't burn the fat well, and their mitochondrial function falls. So these are the two extremes. The carbohydrate extreme needs to eat a lot of carbohydrate. The fat extreme needs to eat a lot of fat and very little carbohydrate, because it kind of works like this. Your body can store a lot of fat, but your body can only store a small amount of carbohydrate, the molecule called glycogen. And you can run out of glycogen very quickly. You can't store much. You're not going to run out of fat, but you can run out of glycogen pretty quickly. And if you're a person whose mitochondria tend to burn glucose very efficiently, you better feed that engine. you better be eating some carbohydrates on a fairly regular basis to have optimal mitochondrial function. But if you're a person who doesn't burn glucose very well and needs to burn fat, the opposite is true. Because if that person eats carbohydrate, what'll happen is bad. When you eat the carbohydrate, it immediately causes your body to produce insulin. The hormone insulin's a great hormone, but one of the side effects, or one of the effects of insulin, is to decrease fat burning, decrease fat metabolism. So let's say you're a primary fat burner, you eat carbohydrates, you've just decreased your ability to burn fat, you don't burn carbohydrates so well, bingo, you're in a world of hurt. Your mitochondria are going to suffer. So you kind of need to know where you stand on this spectrum. And what's so cool about the bioenergy testing system is looking at the ratio of oxygen to CO2 produced while you're sitting there quietly in their chair tells me if you are primarily burning sugar and your mitochondrial function is great, that tells me you're a person that needs to eat a lot of complex carbohydrates. Because if you don't, your mitochondrial function is going to suffer. Conversely, if you're a person who mitochondrial function is low, but you're not burning fat well, that tells me that something's getting in the way of that, and that's probably carbohydrate. You're probably eating too much carbohydrate, and that's interfering. In that case, you need to cut the carbohydrate out and concentrate mostly on eating fat. So those are the two extremes. So basically, it breaks down like this. Some people are not going to have good mitochondrial function unless they eat primarily fat and very little carbohydrate. Other people are not going to have good mitochondrial function unless they eat primarily carbohydrate and not so much fat. And then the rest of us fall in between. Some people fall right in the middle, and they can eat fat, carbohydrate, whatever. It doesn't make much difference for them. But a lot of people, particularly Americans, tend to fall in that section that has to burn fat. And for them, carbohydrate's a pretty bad deal. Now, I can tell you this, or learned this very early on. I remember, never forget this guy. He was a 44-year-old movie actor from Southern Cal. He was out of work, so he spent a lot of time in the gym. He was working out. He looked like Adonis. He was beautiful. He looked like the picture of health. And he came in, and we're talking, and I measure his mitochondrial function. It's lousy. It's at 70%. And, you know, that's unusual. I talked to him, and what I learned was that although his diet was pretty much pristine, his sin was twice a day he typically would have a Dairy Queen Blizzard, which, if you don't know, a Dairy Queen Blizzard's like a milkshake with cookies in there. It's very high level of carbohydrate. That would immediately shut down his fat metabolism and make him rely on carbohydrate metabolism. But this guy was a primary fat burner, so he couldn't burn the carbohydrates all that well, and his mitochondrial function was low. It's amazing, but I told him, I just want you to stop eating those. Don't do anything else, but just stop eating these blizzards twice a day. Don't eat any of them. Stay off carbohydrates. You digest as usual, but stay off of those things. Come back in 2 weeks. I measured his mitochondrial function. It's like 130%. If you're a primary fat burner and you eat carbohydrates, you just shut down your mitochondria almost instantaneously. And I've done this enough to know, because I can get somebody in anybody, actually, this really works for anybody, no matter what your thing is. I can get you in. And if you're showing me that you burn fat really well, I give you a piece of bread, bring you back in 45 minutes, retest you, and guess what? You're not burning fat at all. You ate the bread caused the insulin to be secreted, the insulin shut down the fat metabolism, and you're not burning any fat at all. It happens to 100% of people. And it happens almost immediately. So that's okay if you're the carbohydrate burning type. That's fine. Eat all the bread you want. But if you're the fat burning type, that's poison to you. and it's going to knock out your carbohydrate, and that's going to limit your mitochondrial function and make disease more of an option for you. So, which are you? Are you a primary fat burner or are you a primary carbohydrate burner? That's what you need to know. You can determine that by looking at your bioenergy test, because that's going to determine the kind of diet you should have. Once again, if you're a primary fat burner, you're the type of person that will not have good mitochondrial function unless your diet has very little carbohydrate and a sufficient amount of fats. And I mean good fats, by the way, not just any old fat. On the other hand, if you're a primary glucose or carbohydrate burner and you don't have enough complex carbohydrates in your diet, your mitochondrial function is going to suffer as a result. Now, if you're somebody in between, won't much matter. But the good news is that using the data we get from bioenergy testing, we can determine where you are on this spectrum. And we can advise you how your diet ought to be for optimum mitochondrial function. And that's really critical. So far we've discussed overall mitochondrial function, how it determines your health. We've looked at how important thyroid is, and we looked at resting metabolic rate and how that can't be determined from thyroid blood tests, and that you could very easily have poor thyroid function leading to poor mitochondrial function, even if you have perfectly normal thyroid blood tests. We now just talked a little bit about how your diet plays such a big role, whether you're a primary fat burner or a primary carbohydrate burner. And now finally, we're going to talk about exercise, because of all the things that we can do to have optimal mitochondrial function, exercise is right at the top of the heap. So we'll discuss that in the next part of our series, Disease is Optional. I'll see you there.